right? Like, what really are we talking about when you are talking about functions? So, a function is a rule by means of which each element of the domain, remember all your input values are called your domain, right? Is associated with one element of the range. All your output values are range. So one input goes to one output. One input goes to one output. One input goes to one output. That is what a function is. Now, a function that is like this, where each input gives its own output, is what we call a one-to-one function. Okay, one-to-one function. Right, because as you can see, negative 2 is going into 1. That's it. 4 produces 6, 5 produces 7, 3 produces 9. Okay, so that is a one-to-one function, right? Because one input gives one output. So it is a one-to-one function. Right. Now, what about this one in B? Let's see what's happening here in B. Okay, there. Right. Negative 2 gives you 16, 0 gives you 4, but 1 also gives you 4. So look here. One input, one output. One input, one output. Yeah, it's possible for two inputs to end up going to one output. So it's still a function, okay? So when you have this kind of scenario where you've got two or more inputs to one output, then that one is what we call a many-to-one function. A many-to-one function. Okay. So you can have two inputs giving you one output, right? Okay, now let's see what's happening at C here. Right, we've got this one. Negative 2 gives you 16, 4 gives you 1, but 4... So now we've got one input giving two outputs. Okay, let's just go back to our definition a little bit. Let's read our definition properly. What does our definition say? A function is a rule by means of which each element of the domain is associated with only one element of the range. That's our definition, isn't it? So, our definition says what? Each element of the domain is associated with only one element of the range. But we have got one element of the domain which is now associated with two elements. That is against our definition, isn't it? That's not the definition that we say. So something like this is not a function. Yeah, it's something else that is obviously beyond the scope of grade 12 mathematics. But that cannot be a function.
So I thought it's one-to-many functions as well.
Yeah, a one-to-many function, that kind of thing actually does not exist. What is going on with this thing now? When I'm busy. Okay, forgot to make it full screen. So, yeah, a many-to-one function is there. A one-to-many function, there's actually no such thing. Okay, so when it's one-to-many, then it's not a function anymore. It's something else, right? So let's understand that. Okay. All right. So next page. Now, usually our functions, okay, our functions, we know them to be equations, right? Usually we're just given f of x is equal to that with all the graph, and then that's how we know that it's a function. But, but not everything that you're going to have an equation for will be a function. Okay? So now let's see, how do we know which one is a function and which one is not? Okay? So we can use a ruler to perform what is called the vertical line test on a graph to see whether it is a function or not. Like, let's look at this one A there, okay? So obviously this is a function because as you can see, x is your domain, y is your range, right? It's always like that. X is your domain, y is your range. So the domain here of -2 gives a y of -1. An x of -1 gives a y of 0. X of 0 gives a y of 1. And x of 1 gives a y of 2. We're not going to join with a straight line because we don't know what's going to happen in the front end. We're not concerned about it right now. Okay, so obviously this is a one-to-one function. Because as you can see, one x value is giving you one y value. Okay, one x value gives you one y value. One x value gives you one y value. So it's a one-to-one function.
I'm going to get it. So the circles that
we are going to get to the circles. Yes, hold on. We are going to get there, and we're going to investigate the circles. All right. Okay, so this one, it's obviously a straight line, right? Because this one, obviously, if you are going to look at the domain of this one, for example, the domain is what? A -2, a -1, a 0, and a 1. That's your domain, right? But this one, anything can be a domain. So even -1,995 will be the domain, which was not the case here. So in this case now, the domain is any real number will be a domain. Okay, let me write it here. Any real number will be a domain. Okay, because it can also include commas as well. So 1.5 will be part of the domain. A half will be part of a domain. -half will be part of the domain. So it's still a function. Because if I take, let's say, -1,2, for example, on the x-axis, I'll get a value for the y-axis, right? But I'll get only one value for that. So this is still a one-to-one function. Okay, that's a one-to-one function, right? This one, right, we're gonna use our vertical line test to do that. I don't have a ruler, so I'm just going to draw a vertical line from any point on the graph. So even if I draw a vertical line here, remember from any point, it must cut this graph only once. Then it's a function. Okay? But now we want to check, is it one-to-one or is it many-to-one? We're going to draw a horizontal line now and see. Right? If I draw a horizontal line, it's going to cut on 2 points. Yeah. Remember, I can draw this horizontal line anywhere I want. Oh, okay, but within the curve, of course, not above. So it's actually cutting the curve 2 times. So this now makes it a many-to-one function. It is a function because the vertical line cuts only once. Okay?
So why are you cutting?
That is how we know whether this is a function or not. We want to check, is it a function, yes or no? So if you go back to the notes that are the vertical line test there, see, we can use a ruler to perform the vertical line test. So the vertical line test says this. The ruler must cut the curve only one time. Then it's a function. If it cuts the curve more than one time and it's a vertical line, it's not a function anymore. Okay. So that's what we're testing for here. So we drew our line, it cut only once as a vertical one, so that's a function. But if I draw a horizontal line and it cuts 2 times, then that is many-to-one. Because you can have 2 x's for one y value. Okay, same thing with your standard parabola. You know, that's a parabola. You know this one, right?
Yes.
You've seen this thing before, so you know it. So let's test the parabola. Is it a function? By the way, we did parabolas under functions. And the vertical line cuts only. Listen, draw it from anywhere you want, even the other side, it's still the same thing. Okay? It cuts only once, so yes, it's a function. And we were right to actually do parabolas under the topic of functions. So it is a function. Now if I draw a horizontal line from any point, that's a many-to-one because it's counting. You see, that's why when you find x-intercept for a parabola, you find 2 values.
So when it's
Okay.
so when the vertical line
Cuts only once.
cuts only once and the horizontal line only once, and it's 1 to
It's 1 to 1, yes. Okay? Mm-hmm. Okay, so that's a many to 1. Right. This one, well, it's a straight line going this way, so it's still 1 to 1. Because 1x input gives you 1 y output, so this is a 1 to 1. Function. Okay. Someone was asking me about the circle. Okay, let's test the circle. First of all, let's do the vertical line test. Any point. I don't have a ruler, so I'm just going to have to do it with my free hand. This one is cutting 1 and 2 times, so that's not a function. That is why you see when we did the equation of a circle, we did not do it under functions, because it's not a function. So that's why the equation of a circle is not under functions. It's under geometry. Because it's now something else, not a function.
Why is it not a function? Please, one nothing.
But it's cutting the curve on this point and that point. It's cutting the curve twice. The vertical line must only do it once. This one did it 2 times. So it's not a function anymore. No, we are not going to do this because it's not necessary anymore. It's not a function. We are going to waste our time if we start doing that. So let's just say that this is not a function. Okay. This is something that you have to write down in your notes and remember, because when you do inverses, we're going to need this knowledge a lot. Okay?
You're doing inverses already?
Tomorrow we're going to start with the inverses already. Okay? Right. Let's see. What else do we have here? Oh, right. We still have some more things to test. Okay. Now, you now tell me that G there, is it a function or not?
Yes, it's
Because if you draw a vertical line, it's only going to cut once, right? Don't worry about the asymptote, because the function is not even there, the asymptote anyway. So it is a 1-to-1 function, because 1x gives 1y. So this is 1-to-1 function. By the way, this thing, what kind of a function is it? Is it a parabola? It's a hyperbola, right? There we go.
So you don't like hyperbola?
No, it's just a 1-to-1 function. Or, right, just a small thing that you might need to know. All parabolas are many-to-1 functions. All hyperbolas are 1-to-1 functions. All exponentials are 1-to-1 functions. All linears are 1-to-1 functions. Those are the functions.
So boring. All hyperbolas are what?
They are 1-to-1. All of them. Let me just list it like this. Hyperbolas, exponentials, linears, all of them, they are 1-to-1.
Okay.
Then the parabola is a many-to-1.
Hyperbola and exponential and linear. That is 1-to-1. And the parabola is
And all your tricks are many-to-1. Don't worry right now. Just know that they are many-to-1. All your tricks, so sine, cos, and tan, all of them. Right, this h here, is it a function, yes or no?
No.
Why? Yeah, right, it's not a function. Why?
Oh, okay. Because you can't, nothing is going to be cut forward.
Yeah, it's a vertical line already. It's gonna cut like on an infinite number of points, like 1,000 or 1,000,000. We don't know. Okay, so this one is obviously not a function. Okay. Now quickly, Let's just quickly write down the domains and ranges of each of the examples we did here. The ones that we found to be functions. If it's not a function, there is no domain or range to talk about. Okay, so A, I did give you the domain. It's these ones, -2 and -1 and 1 and 2. Okay. B, this arrow means this line is going to go on and on. And this is going to go on and on. So any real number is the domain. Oh, yes, the range. So this one, the range. Let's see the outputs that we have here. The outputs that we have there, we have -1, we have 0, we have 1, we have 2. That's our range. But now with this one, our range, well, y is any real number. So you can basically get any real number from this one. Okay, so let's look at C, our domain. Well, as you can see, this is starting from -2, going all the way to +2. Can't go further than that. So our domain here is any x that is less than or equal to x less than or equal to 2. So it means anything between -2 and +2, including the 2 and the -2. That's how we have less than or equal to. The range from this starts at -2. So -2 is actually part of the domain, the domain, all the way up to 2. So that's why we're going to write it like this. This is a mathematical way of saying x is between -2 and +2.
So what if we write that at B?
At B, because this graph is going to go on forever, and it's going to go on forever.
Now why didn't we write that?
So every time it cuts twice, so then you must write it like that.
No, look at where your graph is starting. Where is it starting? At -2 here. Where is it stopping? At -2. Can it go further than that? No. Can it go beyond this? No. So this is the values that it can only take. So, and then just mention also that x would be a real number. Okay. Because there are some functions where you're only going to take integers. Like a, you could only take integers. Part D, that's a standard parabola. And this is what we know about parabolas. Okay, so the domain is any real number. And the range, well, isn't it? This one has got a turning point at +1. And it's upwards like this. It's a smiley graph. So obviously the range, it's a y greater than or equal to 1. Remember, that's what to do with smiley graphs. If it was frowning, it was going to be less than or equal to. Oh, and then also specify that y is a real number. E is different because we can actually see that it's starting at -4. We can see it here. Okay, because this graph is not, it's like different from B. B had an arrow there, which means the graph is going to go on. Okay, but this one is stopping here, and it's stopping here. So our domain, if you remember, do you still remember your number lines from inequalities? If you shade this in, it's less than or equal to, isn't it? You remember that? With the inequalities, if this thing is shaded, it's less than or equal to. So -4 less than or equal to x. But now if this is not shaded in, then it's a strict inequality. So that's less than 7. Okay. And it looks like any real number will work here. So which means the range now is this. Y takes a minimum value of -1 because it stops here. So it's going to be -1 less than, strictly, because this is not shaded. Y, sorry. Less than or equal to, because that's shaded, 5. And also just mention that y is a real number. Right. This, if we discover that it's not a function, there is no domain and range to talk about here because it's not a function.
So that it's
Yeah.
just like that.
We can't talk about domains and ranges of things that are not functions. It's a waste of time. Okay, and then on G here, where is it? Oh, there. Right, on G here, the domain, this is a standard hyperbola, right? So x can be any real number, but x cannot be equal to 0. As you can see, that's our asymptote. 0 is an asymptote, so x cannot be 0. And for the range, y can be any real number, but our y asymptote is 0, so y cannot be 0. So, but h is not a function, so there's no domain and range to talk about it. Okay, does that make sense now? All right. Okay.